Light is one of the most familiar things in our daily lives and also one of the most mysterious. It lets us see warms our planet, powers plants, and travels across the universe to tell us stories from distant stars. Yet when scientists asked a simple question, what exactly is light, the answer turned out to be far from simple. Light behaves like a wave and like a particle depending on how we observe it. This strange behavior is known as wave-particle duality, and it completely changed how we understand reality itself. For a long time, scientists believed light was a wave. This made sense because light shows behaviors common to waves, such as reflection, refraction, and interference. When light passes through a prism, it spreads into a rainbow of colors just like water waves spreading out after hitting an obstacle. Experiments showed that light waves can overlap, cancel each other out, or amplify each other, creating bright and dark patterns. These observations fit perfectly with the idea that light is a continuous wave moving through space. But then came a major surprise. When scientists studied light interacting with matter at very small scales, it didn't behave like a smooth wave at all. Instead, light arrived in tiny discrete packets of energy. These packets were later called photons. For example, when light hits a metal surface, it can knock electrons free, but only if the light has enough energy. Increasing brightness doesn't help if the energy per photon is too low. This behavior makes no sense for a classical wave, but it makes perfect sense if light is made of particles. Even more puzzling, light can act like both a wave and a particle at the same time, but which behavior we see depends on how we measure it. In experiments where light passes through two tiny slits, it creates an interference pattern, a clear wave property. But if we try to observe which slit the light goes through, the interference pattern disappears and light behaves like individual particles instead. Simply observing the system changes the outcome. This is not a trick or an illusion, it is a fundamental rule of nature. Wave-particle duality tells us that light is not either a wave or a particle in the traditional sense. Instead, it is something deeper that doesn't fit neatly into everyday categories. Light follows the rules of quantum physics, where probabilities replace certainty and observation plays an active role. Before measurement, light exists as a range of possible outcomes. Only when we observe it does it choose how to behave. This strange nature of light isn't just a theoretical curiosity, it powers much of modern technology. Lasers, solar panels, digital cameras, fiber optic communication, medical imaging, and even quantum computers all rely on the dual nature of light. GPS satellites must account for quantum effects to remain accurate. Without understanding wave-particle duality, the modern world as we know it would not exist. On a deeper level, light challenges how we think about reality. It reminds us that the universe doesn't operate according to human intuition. Things can exist in multiple states, behave differently depending on observation, and defy simple labels. Light teaches us humility. It shows that nature is far more subtle and beautiful than our everyday experiences suggest. So what is light? Light is energy, information, and motion all at once. It is a wave spreading through space, a particle delivering precise packets of energy, and a quantum phenomenon that bridges the visible world and the invisible rules beneath it. Every time you turn on a lamp or see sunlight touch the earth, you are witnessing one of the greatest mysteries ever discovered, quietly happening all around you. If you enjoyed this deep yet simple explanation of light and the strange rules it follows, share and subscribe for more fascinating science stories that reveal how the universe truly works.